Alright, stoichiometry is not nearly as difficult as sometimes chemistry students think. It's basically kitchen chemistry, really. It's trying to figure out how much stuff you could make if you know how much given you have, or maybe how much given you need if you know how much stuff you want to make. And like in the kitchen, we have recipes. We have reactions or chemical equations in chemistry to tell us what kind of stuff we need and what kind of stuff we're going to make. So we'll just jump right into a problem here. Let's look at the recipe for making rust. We make rust out of iron and oxygen, as most of you know. So if I just write down the general recipe or the skeleton recipe, we know that we have some iron, and we're going to add some oxygen to it, and of course oxygen is diatomic, and we'll be able to make some rust, and the equation for rust, or the formula for rust, is Fe2O3. Iron is being oxidized here. So of course this is just a general recipe. We need to know a specific recipe, which means we need to balance this equation. So if I put a 2 in front of this, I can make 4 irons, and I'd put a 4 in front of that, and I would need a 3 in front of the oxygen to make 6 oxygens, and so now it would be balanced. So this is the recipe for making rust. Let's assume that in this first stoichiometry problem that we are attempting, we know that we have 140 grams of iron. 140 grams of iron. And I want to know if I have an unlimited supply of oxygen, because I live on the earth, so I do. I have more than enough oxygen I need. I don't need to figure. I'm not figuring out in this problem exactly how much oxygen I need to react up every last bit of the 140 grams. Although we could easily do the same kind of stoichiometry problem to figure that out. I'm going to assume that I have an endless supply of oxygen, so I'm going to have as much oxygen as I possibly need to react up all 140 grams of the iron. How many grams of rust would I be able to make? That's the stoichiometry problem. How many grams of rust would I be able to make if I had 140 grams of iron? So the way we do this stoichiometry problem is we, of course, write down the given. So I take 140 grams of iron, and I'll always want to convert that to moles, because this recipe shows you the recipe is in moles. It says that there's 4 moles of iron reacting with 3 moles of oxygen will produce 2 moles of rust. So we have a mole ratio. For every 4 moles of iron, we're going to make 2 moles of rust. So that's important. So when I'm doing my stoichiometry, I can't leave it in grams. I can't say that since there's 4 moles of iron, there's only 2 moles of rust, that I need twice as more moles of iron than I do rust. That's obvious. But does that mean I need twice as many grams of iron as I do rust? For instance, am I going to end up making, just 70 grams of rust because I'm starting with 140 grams of iron? Well, that obviously can't be the case, because a mole of something has different masses, right? When a mole of iron has a different mass than a mole of rust. So the ratio in this recipe is in moles. So whenever I have something in grams, I need to convert it to moles to be able to use the recipe. So the first thing I'm going to do here is convert my 140 grams of iron into moles. So 1 mole of iron, you've used these before, 1 mole of iron is 56 grams of iron. So grams of iron will cancel out, and I'll be in moles of iron. Now that's important then, because now I can use my recipe. I can write, okay, for every 4 moles of iron, would I put that on the bottom or the top? Well, I need moles of iron to cancel out, so I'm going to put it on the bottom. For every 4 moles of iron, I will be able to make 2 moles of rust. 4 to 2. So my moles of iron cancel out, and now I'm in moles of rust. And so now all I need to do to figure out how many grams of rust I'll be able to make is to convert from my moles 1 mole of rust back in to grams. And what is 1 mole of, what's the molar mass of rust? Well, you'd have to add that up and figure it out, and you'll see that it's 160. Now, keep in mind, when I add up the molar masses of these things, I'm not including this coefficient thing. I'm just saying what's the mole of the actual compound, or what's the molar mass of the actual compound. So Fe2O3 has a molar mass of 160. You don't have to worry about multiplying by 2 because, see, we're going to do that right here. Okay? So my moles of rust cancel out, and I would be, I could do my math here on my problem, and I take 140. If I did the math down here, it'd be at 140 times 2 times 160, divide by 56, and divide by 4, and I get 200 grams of rust. 200 grams of rust. Okay? So if you look at this, this is a stoichiometry problem, is all it is. And if you look at it, really, what did all we do? Well, we took our given in grams and we converted it to moles so that we could do stoichiometry, so that we could actually put in our ratio of 4 to 2 right here in the center. So we took our grams, we converted it to moles, then we figured out, okay, for every 4 moles of iron I have 2 moles of rust, and then once I was in moles of rust, I converted it back to grams. Okay? Now, if that means we're going to make 200, if we're going to react all 140 grams of the iron and we make 200 grams of the rust, how many grams of oxygen do we actually need? Well, we have conservation of mass, so if we had used 140 and we got 200, we would need 60 here. 140 plus 60 is 200. Our mass needs to be conserved. So that's a real easy way then to figure out how many grams of oxygen we needed. Now, of course, in this problem, this could be an easier stoichiometry problem. I could say, I could do something real simple that we wouldn't have to really do much math with at all. I could say, all right, we have 10 moles of iron. How many moles of rust could I make? 10 moles of iron, how many moles of rust could I make? I don't think you probably even need to do any work. You probably do that in your head. Because if 4 moles of iron makes 2, the ratio is 2 to 1, right? 4 to 2 is 2. 4 to 2 is, 2 to 1. So 10 would make how many? Well, it would make 5. So if I had 10 moles of iron, I can make 5 moles of rust. So you can do that with moles. You can't do that with the grams. If you're in grams, you got to convert it to moles and then do that. So 4 makes 2, 6 would make 3, 10 would make 5. If I'm just in moles, then these are really easy problems. You don't really hardly have to do anything to write down. But usually I'm going to give you a given in grams. You need to figure out how many grams of something else that is. So you're going to convert it to moles, put in your mole ratio, convert back to mole, or convert back to grams. So that's kind of what you do on that problem. All right. Let's do one more here. Let's say we have we're going to make some. We have calcium chlorate. Calcium chloride is KClO3, and that's going to be a decomposition reaction. I would heat this up, and I would get some oxygen gas, and I'd get some potassium chloride. Okay, and I want to know. I want to make 30 grams. I want to make 30 grams of oxygen. I want to generate 30 grams of oxygen. How much potassium chlorate would I need? Potassium chlorate would I need to be able to make 30 grams of oxygen? Okay, the first thing we need to do is, of course, balance the equation. We always have to balance the recipe, find out our mole ratios. So if I put a 3 there, 6 oxygens, I'd have to have a 2 there and a 2 there. So the ratio is 2 to 3 to 2. But the things that are important are this one and this one, because this is how much, this is my unknown, and here is my given. And my ratio is going to be 2 to 3. So the first thing I do, of course, is I write down the given. I have 30 grams of O2, and I need to convert that to moles because I want to do my mole ratio of 3 to 2. So 1 mole of oxygen, diatomic, is 32 grams of oxygen, and my grams of oxygen would cancel out, and I'm in moles. So now I can put in my mole ratio of oxygen to potassium chlorate. So I would need 3 moles of oxygen to every 2 moles of KClO3. So my moles of oxygen cancel out. I'm in moles of potassium chlorate. And then all I have to do then is convert it back to grams. 1 mole of potassium chlorate, if you add it up, I hope you would get 122. Hopefully you're pausing this movie and trying these things on your own. Potassium chlorate moles would cancel out, and I'd have my grams. And if I did all the math here, it'd come out to about 76.3 grams of potassium chlorate is how much I would need if I wanted to generate 30 grams of oxygen. Now, of course, if I did that, that would mean I would have 46.3 grams of potassium chloride left over too. That's not part of the problem, but conservation of mass would mean that is true. So hopefully you can see that stoichiometry problems aren't that bad. Usually you're given grams, you convert it to moles, be able to put the mole ratio in from the recipe, and then convert it back to grams on the other side, or maybe the same side, depending on whichever you're trying to find out.